All right, crew. Today we are going to finish our discussion from Friday, where we looked at how to find the area and the perimeter of composite shapes. So those are shapes that are made up of other shapes. Can you please show me your hand signal from Friday that you used to remind you of what perimeter is? Love it. I see you guys drawing some boxes in the air. Will you show me your hand signal for area? Okay. I see a lot of you showing something like what's inside. I like that. How about, let's do a new one. Can you show me a hand signal for composite figure? Okay. It might be like a rectangle connected to another rectangle. Perfect. Okay. We talked about that in order to find the area of a rectangle, we use the formula area equals length times width. So we're going to build on that today. We reviewed area and perimeter with fractions. We did some work with composite figures. We talked about two different strategies. One of them, at the bottom here, was to break our figure up into other shapes. And then the second one that we talked about was starting with one figure and then subtracting parts out. I hope when you do your cool down today that maybe some of you will use that strategy. So we're going to do a few practice problems today just to get your brain going for the week. Our first problem that we have is to find the area of this shape over here. Remember that area equals our length times our width. So very quickly, I'm just going to do some estimating here. And I want to estimate the area of this figure. 2.25, 2 and 25 hundredths is close to 2. And 3 and 5 tenths is close to 4. So my area should be somewhere close to 8 square centimeters. So now with the formula that I drew in, and I hope you're following along and you're writing this down with me. We're on page 2 of your geometry section. I'm going to substitute, instead of saying length, I want to say 2 and 25 hundredths. I'm going to use a dot to denote multiplication, and I want to multiply that times 3 1/2. So I'm going to set this up as an algorithm over here. Okay, I'm going to stack this problem. When I multiply decimals, I do not need to line up my dot, but I do still need to give it all I've got. So 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. 5 times 2 is 10, plus 1 is 11. I'm going to put my 0 in as a placeholder there. Cross off those little parts that I carried, just so I don't get confused. 3 times 5 is 15. 3 times 2 is 6, plus 1 is 7. And 3 times 2 is 6. So now I'm going to add together all of those parts. So I have 5, 7, 8, and 7. Remember how I said that my estimate was going to be close to 8? So the place that it makes the most sense to put my decimal is between the 7 and the 8. But also if I look at my original problem, I see that I moved my decimal over 1, 2, 3 places. So I have 1, 2, 3. So either way works. Yeah. You could do 7 and 7/8 as well, absolutely. Okay, we are not finished because we also need our label here. This is area. Our units were centimeters. So we have 7 and 875 thousandths centimeters squared. Let's go ahead and circle that. Okay, so for our work today, we have our drawing, we have our work, and then we have our answer clearly circled. Okay, the next thing we need to work on is finding the perimeter. Okay, we're just going to make sure that we add together all 4 sides, that we don't forget any of them. So I have 2 and 25 hundredths. And I actually have 2 groups of those because both the top and the bottom. And then I have each of the sides for 3 and 5/10. Now, I need to make sure to line up my decimals here. And if you want to, you could also put in a placeholder here. Just that's optional. In my hundredths place, 5 and 5 is 10. In my tens place, I have 3, 4, 5, 10, 15. Carry a 1 to my ones place. 1 plus 2 is 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 and a half, and this one will just say 11 and a half centimeters. When we do perimeter, it's in units. Area is in units squared. And then volume would be in units cubed. Okay. The next one we're going to look at is a composite shape. It's several shapes together. Crew, would you like to see me use strategy 1 where I break it apart? Or do you want to see me use strategy 2 where I do a bigger shape and then subtract from that bigger shape? 2. Okay, I'll do strategy 2. Those of you who feel like you're ready for a little bit of a challenge, I want you to try strategy 1 and then compare your answer with me, okay? Make sure that you're taking your notes in pencil right now, please. All right, so you guys wanted me to do strategy 2, and just as a reminder, that's when I find the area, I surround the whole shape, and then subtract out anything extra. So I want to start by finding the area of this whole shape here. Okay. And then I'm going to subtract out this piece right here. Okay. So in order to write that out, I want to say that my area equals. Okay, I want to figure out this whole big shape here, but I have to figure out some of my missing lengths. So I know that in order to find this value along the bottom, I have 2 other pieces that are going to add up. So this 2.5 plus this 1.5 will add up to be the length of that bottom piece. So 2.5 plus 1.5. Crew, what is that? 4. Thank you. I heard a couple of you. They say, Crew, you can all answer. So I have the area of the whole thing is 4 times 4. Okay? So that's everything here. But now I want to subtract out that piece in green. Okay? Which means I need to find both of the dimensions. So I know that this piece along the bottom is 1 and 5/10, but I also need to find the length of the other dimension, okay? So looking at this, if I know that 4, this whole side here is 4, and this piece here is 2.5, this part here needs to be the difference between 2.5 and 4. So what's that going to be, Crew? 1.5. Thank you. Okay, so the dimensions of that piece will be 1.5 times 1.5. Okay, so let's do our math here. So my area equals, in total, the whole big shape there was 16. Now I have 1.5 times 1.5. I'm going to do a little bit of work off to the side here. 5 times 5 is 25. 5 times 1 is 5, 6, 7. Put my 0 placeholder. 1 times 5 is 5. 1 times 1 is 1. So I'll add all these. Put my decimal point between my 2's. So then I'm going to subtract out 2 and 25/100ths. For my final answer, that means that my area here will be 13 and 75/100ths. We're doing area, so that will be centimeters squared for that. So once again, I started off by finding the area of this whole piece, and then I subtracted that little part that wasn't there. Okay, So let's find the perimeter. I count up a total of 6 sides. So as I'm stacking everything, I'm going to go ahead and just make sure that I have 6 different values. I'm going to start with this 4 right here, and then just go around clockwise. So I have 4. I'm going to make that 4.0 just because I have some other values that are in the tenths. Plus 2.5, 1.5, 1.5, 2.5, and then 4 along the bottom. So I have 1, 2, 3, 4, 5, 6 answers. All right. In the tenths place, 5, 10, 15, 20. In the ones place, I have 2 plus 4 is 6, 7, 8, 9, 10, 11, 12. Plus 4, I have 16. And what's my label, crew? Centimeters. Centimeters, you got it. Now, what's my last problem on this page? I recommend that you break it up. I think it would be trickier to subtract out things, but really, you can do it however you would like to. So I'm going to break it up. If you want to practice subtracting pieces out and then check your answer with me, sounds great. So I want to break up my figure into 3 different quadrilaterals, or rectangles in this case. I'm going to start with this piece right here. Okay, so this piece in green. I have that my area equals. Okay, the dimensions of this green piece here are 2 times 2. I also noticed that there's a 3 up here, but that's this entire distance right here, which that's not what I'm looking at. So starting off with 2 times 2, so the area of the part in green is 4. And now I'm going to do this piece right here in blue. And I also need to find my dimensions for this one. I can see that there are other pieces there that look like they're also 1, but I'm not going to rely on that. I want to make sure that it's totally accurate. So what I can see is, in order to find this distance right here, this whole piece right here is 2. And so I've also been given, thank you, I've also been given the dimensions for this part right here. So 2 minus 1, that means that this remaining piece here has to be 1. Also along the top right here, if I've been told that this whole distance here is 3, okay, all of this is 3, and then this is 2, that means that this remaining part right here also has to be 1. So that'll be 1. So for that little piece right there, I'm going to add 1 times 1. Okay, the last piece that I want to do is this in pink. Okay. So also here, I see that this is 2 and this is 1. So add those together, that gives me this whole piece right here, which is 3. So 3 times 1, that part in pink is 3. Oh, I forgot to do the part in blue. So 1 times 1 is 1. When I add those all together, I have that my total area is 8 centimeters squared. Okay. Now here comes the part that actually is going to be really easy to add, but it's going to be imperative that we don't miss any of our sides. Will you guys count up how many sides we have here? 7. We got 7. Did anyone get a different number? 8? Let's see. I got 9. I'm going to trace around this shape. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just like 10 sides. So I have to make sure that I add up all 10 of those. Okay, even if they don't have a number, we still have to add them in. I noticed I'm missing one of the dimensions from my sides, which is right in here. It's the same length as the one across from it, so that's also going to be 1. Okay, so I'm going to make sure that when I add together my perimeter, that I have 10 pieces of information that I'm adding. I'm going to start at this 2 right here and go around clockwise. Okay, so I have 2 plus 3 plus 1 plus 1 plus 3 plus 1 plus 1 plus 1 plus 1 plus 2. Let me make sure I have 10 sides here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Add them together. 2 plus 3 is 5, 6, 7, 10, 11, 12, 13, 14, and then 16. And what's my label, crew? Centimeters, exact. Okay. And I'll circle my answers in these 2 places. All right, let's head to your next page. We have a couple more we're going to do together here. So this says exactly 187 feet of fencing is used to surround the garden below. Okay, so that might also be known as the, what value have they given us, guys?
The length.
What do we call it? All the sides added up together.
Perimeter.
The perimeter. Yeah, we call that the perimeter. Okay, so we know from the work that we've been doing that perimeter is equal to the length. Remember, that's my L for length, so it doesn't look like a 1. Plus the length, plus the width, plus the width. Now let's go in here and replace our variables with the values that we actually know. So we know that perimeter is 187. Okay. We also know our lengths, and we know that those are 24 and a half. But we still don't know our widths, so we have to figure those out. I'm going to clean this up just a little bit. So 187 is equal to 24 and a half plus 24 and a half. What's that going to be?
49.
Thank you. That's 49. And then I'm going to write this as 2 groups of the width. So I'm going to write 2W. That means 2 groups of the width. Now, as I work through this, I'm going to explain to you what I'm doing, but I'm also going to give you a little taste of solving equations that you'll do in 7th grade. So I know that the total perimeter is 187. And from that, 48 of that is the length. So I want to take out 49. I want to subtract 49. Which means that 187 minus 49 is 138. So that means that the 2 widths added together are going to be 138. So let me show you this again. Everything added together is 187. Okay? All of this added together is 187. From that, I subtracted 24 and a half, but I subtracted both of those. So I'm left with 138, and that's how much both of the widths are together. So now what I need to do is to divide this by 2. 138 divided by 2 is 69. So my width is 69. I'm going to say 69 feet. Okay, it's just in one dimension. My next question says find the area of the garden. Well, now that I have length and width, I can do that no problem. So I know area equals length times width. In this case, my length is 24 and a half, and my width is 69. Okay. So I'll go ahead and stack these. 24.5 times 69. All right, 9 times 5 is 45. 9 times 4 is 36. Plus 4 is 40. 9 times 2 is 18. Plus 4 is 22. Put in my 0 as my placeholder. Cross off this part that I carried just so I don't get confused. 6 times 5 is 30. 6 times 4 is 24, plus 3 is 27. 6 times 2 is 12, plus 2 is 14. Add all of that together. Let's get close to my other answer. All right, make sure I pay attention to that decimal point. I need to move it over one place. So my final answer is 1,690.5. This is area, so I'm going to do feet squared. Okay, that's a nice sized garden. All right, let's look at your next one. This says it takes exactly 155 square feet of carpet to cover the floor in the diagram below. So if it takes 155 square feet of carpet, what value have we been given? Not the perimeter.
The length.
Not the length.
Area.
You've been given the area, right? Because remember from your pictures that you were showing me, your hand signals, you're showing me what's inside. So we have 155 square feet. Okay, so that's what's inside. So if I know, guys, if I know that the area is equal to the length times the width, and I have the area, what fact family operation can I use to find the length? You guys are taking such good notes, by the way. What fact family can I use? Michaela, what do you think?
Division.
Okay, what do you think it's going to be?
I think it's going to be 155 divided by 15.5.
Okay, can I write that as area divided by width equals length?
Yeah.
Yeah, and then let me put in those actual values that you gave me. So if I use area divided by width equals length, 155 divided by 15.5 equals my length. Good job with your fact families. Okay, let's go ahead and set this up as a division problem with decimal. This will be a really good review for us. So I have 155, I'll switch colors. 155 divided by 15.5. Now remember that we cannot have a decimal in our divisor, so I'm going to move this decimal over one place, which means that I also need to move it over one place in my dividend. So my equivalent problem is 1,550 divided by 155. Okay, let's go through our steps here. 155 does not go into 1, it does not go into 15, but it does go into 155 one time, which is 155. Subtract, I have 0. Bring down my 0. 155 goes into 0 times, which is 0. We're left with 0, we don't have any remainders, okay? So that means that our length is going to be 10 feet. And that makes sense if we make our length 10 feet, because 15.5 times 10 is 155 square feet. So our next problem is to find the perimeter of the room. So we know that perimeter equals, I'm going to say, 2 groups of the length. Perimeter equals 2 groups of the length plus 2 groups of the width. So 2 groups of the length would be 2 groups of 10 plus 2 groups of the width, which is 15.5. So perimeter equals 20 plus 31. So our perimeter equals 51 feet. So we'll write that down. Here's our answer too. All right. So you guys got to see, we started off on Friday, just a real nice review, and we got all the way to be able to use our inverse operations to solve for unknown values. Okay.